Math 13 students, hello. I wanted to run through an example or two of the hypothesis test process. As I noticed on your quizzes, many of you are still working towards an understanding of that process. So I wanted to provide some detailed examples to help you with that. So we're going to do two here. The first is we're going to use a simple random sample to test the claim that the mean number of hours spent per week by a professional athlete is more than 40 hours per week, and we're going to use a 5% level of significance. I see my data. I note that I've got more than 30 in my sample size, so the central limit theorem applies, and there's no problem with using my tools. So the claim is more than 40 hours per week. So that's a claim about a mean, which means I will be using a particular tool. I'll get to that in a moment. So the translation looks like H naught H1 mu equals 40 hours per week. For the null hypothesis, mu is greater than 40 hours per week is the alternative hypothesis. And this is my initial claim. This is a claim that I drew from the statement. So I'm now ready to go ahead and run through the process. That's the first step. The second step is to find my p-value. So I'll come over, I'll grab my calculator, stat, over to test, I'll go to t-test, I've got stats. My claim is that the mean number of hours working out per week is 40 hours per week. My data is 42.3 hours per week with a mean standard deviation of 6.2 hours per week. We had a sample size of 35, and greater than or more than 40 hours per week makes it a right tail test. Now I'll go ahead and I'll hit calculate. There's my p-value. 0.1755 and change, 0.0176. So that's the second step. Third step, I'll compare this to my alpha. The alpha is 0.05. My p-value is less than the alpha. When p is less than or equal to alpha, we reject the null hypothesis. The final step is to address the initial claim. Was the initial claim, the alternative claim, supported by the argument? Well, we rejected the null hypothesis, so we're going to go with the alternative, which was the claim. So, data support, mu is greater than 40 hours per week at alpha equals 0.05 or 5%. There you go. That is your 5-step process. So let me run through another example with a population proportion. So this time we're going to use a simple random sample to test the claim that 62% of students own their own computers. Again, we're going to use a 5% level of significance. So the claim is that the proportion of students that own their own computer is 62%. How do I know it's a proportion? Because it's a percentage. So my null and my alternative hypothesis look like this. P equals 62%. P is not equal to 62%. Don't get hung up on the symbology. Use your words. They're going to work just fine. So it's a claim about a population proportion. I'll bring back Mr. Calculator. I'll use the one-prop z-test here. The claim is that 62% of students own their own computer. This is a two-tailed test, and I've got to remember to use decimals and not percentages. How many X's? 136 said, yes, I've got my own computer, out of a total of 200 people who were asked. This is a two-tailed test. So I'll select the two-tailed test, and I'll hit calculate. I have a p-value of 0.0804 and change. Now, it's a probability, so I round it to 3 significant digits. .05. This time, my p-value is greater than the level of significance, so we fail to reject the null hypothesis. Now, this is where I need to remember that my claim in this particular case was the null hypothesis. So, to address the initial claim, I will note that data support p equals 62% at alpha equals 0.05. 1, 2, 3, 4, 5. Those are the 5 steps. This is really what I need to see when I ask you guys to do a hypothesis test. And there we go. Thank you. We'll end it there.